Welcome to all of you in this video. My name is Sumit Kaur from Impulse Technology, Delhi, Gurgaon. Today in this video, we will demonstrate transistor characteristics of Au-alkanethiol-Au devices. So first we have to create our device. So first open the device studio. Now we will create a new project. I will create this project with name transistor. So as you can all see, this is my device studio user interface in which my project name is transistor. So first we will create the structure, nanostructure of AU alkanethiol AU device. So first we go to the file option and we'll take the AU atom, import local and in 3D materials and conductor, pure matter, and as you can see this is my AU metal. So first this is the AU atom. So go to the build option, click redefine crystal, click phase centric, preview, then build. Now this is the AU crystal. So now do it again. Go to the build option, redefine crystal, and put the values. As you can see in X, Y, Z, I'll put it 2, 2 and 4. Click preview and then click build. Now this is the AU molecules. I have to delete some redundant atom from this molecule. So select this atom. As you can see, there are a lot of tools are there in which we use the delete tools. So here is a delete tool. So now go to the 3D viewer and click XY view and click this redundant atom again using delete option. Now click on 3D viewer and we have to delete some another redundant atoms. This at select these all atoms and unselect this and click delete. As you can see, uh, now the next step is to create some vacuum in for this molecule structure. There is an option called convert to crystal option and put the values. I'll put the 18 for X, 18 for Y, and for Z will be same. And click build and click center along X, then center along P. Now this molecular structure is ready. Now we have to take the another structure. So we will create the mirror image of molecular structure. So select this atom and this is a tool called mirror atom. Click here and as you can see we will select the XY view and we'll take the value of distance in angstrom which will be 6.7 angstrom and click apply. As you can see our mirror molecular structure is ready. Now we need to take this atom and as a whole structure, so we'll create some vacuum between them. So go to the convert to crystal option and put the values here. which will be 40, and click build. Now as you can see, this is your uh, this structure is ready. Now we have to take alkanithyl molecule. So I'll already have alkanithyl molecule. So go to the import and I save. This is the alkanithyl molecule. Click OK. Now I have to. This is your alkanithyl molecule. So now we have to place this molecule into this between this structure. So now we will copy with Control plus C, and using Control V we will paste it here. Now we have to do this molecular into the center. So select this atom, select this molecule, and there is an option called center. Click here. Now as you can see, this is our structure is ready. Now we have to make this structure into this into the device. So go to the build option. There is a tool called convert to device. Now as you can see, as your convenience, there is a electrode options are there. In your convenience you can select them. We'll select the left electrode and right electrode, and there is some default value is already selected, which is which you can see minus 4.0783 and 4.0783 angstrom. So click on preview. Now as you can see, uh, our device is ready. So click on build option. Now this is our device. Now we have to go to the simulator option and click NanoDcal. Using NanoDcal software, we will create a buffer into this structure. So go to the add buffer, and there is a thickness we have to define, which will be the, I will select the, click on plus, your buffer will be shifted to the left, and if you wanted to take on right, you can click on plus on the right button and click build. Now this device is ready. Now our device is ready, which is a AU dash alkanithyl dash AU device is ready. Now we have to make this make the transistor for this device. So go to the simulator option and click NanoDcal. Click on transistor, and as you can see, the transistor for device is tab is open here, in which you can define the gate, IV curve, basic settings, contour integrals, their electrode values, and their iteration control, and their basic set, and their spin type. If you wanted to do with some spin type application, so you can select here. Now we'll go to the gate one. So as you can see, the region type, if you wanted to select their region, our region will be primitive and thickness. And for dielectric, the value will be, for primitive value will be 25, and thickness we can take 4 or 5. I'll take to the 4 angstrom, and this is a channel region. It's default selected, and number of gate is selected, and you wanted to give the gate voltages. We will go to the 0 0.1, 0 0.2, 0 0.3 to 1 voltage. So put the values. 0.9, as whatever you wanted to select this value, you can do from like this. Okay, and here is the option for gate type. Here is the top and bottom gate, front or back gate. Whatever we wanted to select, you can select from your convenience. And the gate region thickness from this to this is uh, ready here. Now the transistor source type, right or left, you can select it from your convenience. what do you want it to give the bias voltages? We will take the 0.2 as default are given. If you have some specific values and specific calculation, you can select from here. Now IV curve, for IV curve, these are the K point sampling for basic settings. You can give their electron temperature, their basic, their energy cutoff values, their exchange correlation type values, and their exchange, their K point sampling value as well. Now for contour integral, there is a values you can select from here, and in electrode you can give their temperature, their electrode voltage you can give, and the iteration control like 0.1 is selected automatically, you can see here. And for basic set, if you wanted to give some Hubbard terms, you can also select it. And if you want specific type of spin type, you can give their collinear or general type of spin. So we will click on generate file. After the clicking on generate file, as you can see, there are a lot of files are shown here, like device, for left electrode, right electrode, and their VD, no, with no gate voltage with 0.2 bias voltage at and gate voltage will be 0.1, as so on. These are all values are shown here. Now you have to run this all calculation one by one. So first we have to go on left electrode and click right click. As you can see, their scf dot input file is ready. If you wanted to see this scf dot input file, you have to simply right click on it and click open with. As you can see, all parameters you have to given for this transistor are shown here, like their uh, temperature, electron cutoff, and exchange correlation value, their K point sampling as all, and their Poisson permittivity, spin type, all types of parameters you can see here, as well as you can see the all type of calculations from here. Now you must have to first run the left electrode. So we will go to the left electrode and scf dot input, then right click on it and click run. And when we click run, then after this you have go to the right electrode, then do it for right electrode, click run. Now for go to the device and click on scf dot input file, click right and click run. Now after doing this, since you all know this calculation in this device studio, calculation are running in queue form. So one calculation when completed, the next calculation will be started. For now, the next step is you have to run the other files, like scf dot input file 0.2 bias voltage at 0.1 gate voltage at 0.2 bias voltage. So you have to go on scf dot input file, click run it, and then run the ivc dot input file, click run. And you have to do with all files. So go to the scf dot input file, click run. For iv dot input file, click run. Now this step is you have to do with simultaneously for all files. For So we'll do it again and again. Now for Since you can see here, our gate voltage and our bias voltage is constant here for 0.1 to 0.1 to 1 voltage. So if you have some specific type of, you are doing some specific type of calculation, you can do for all. So now by that method, you have to run the all calculation. As you can see, for as you wanted to see the status of your calculation, there is a job manager tab in which you can see the all calculations are running, and the mean calculation which are not started, they are in queue form. So if you wanted to see the status, you can simply click on I button. As you can see, our electrode, left electrode calculations are running here. As you can see, and in the log.txt file, okay, open with, you can see the calculations are still in running process. Now, as you can see, our all calculations are done here, and we do the all calculation. And as you can see, the all calculations are completed here, in which I wanted to see you the status of your our calculation. So as you can see, if you wanted to see, all calculations are done here. They are left electrode values, right electrodes, all calculations are completed. And now we'll go to the as you can see, for voltages, there is no gate at 0 voltage, and their IV curve, current voltage curve also you can see here. For all values are completed, calculations are calculated. Now the main thing, we wanted to see the characteristics. So when we open this any of our current voltage curve, we cannot see the analysis. So we must have go to the, since these values are a single point, so for seeing the, for doing the characteristics of this transistor, we have to go on simulator option and NanoDcal, and there is a tool called transistor, and there is another one. This is a transistor plot. You have to click on transistor plot and select the file where you saved your project. So you have to go that project where transistor, and now select the folder that is calculated. And now as you can see, your output characteristics curve are shown here, which is IVD curve, and you can see there are points. As you can see, all points are shown here. So as you can see, these are the all points. As you can see, for 0.1 voltage to 0.2 to 1 voltage. Now we wanted to see with VG, that for gate voltage. Now you can see here, this is the IDVD characteristics for this transistor, in which these are the values. So in that method, you can create your structure and create a transistor for that device, and according to your convenience, you can create their values, input values for transistor, and run it. And after the calculation, you can simply, there are tools called simulate in NanoDcal for transistor plot. You can plot all the values from there. Thank you everyone to watching this video.